Expected value analysis.
Expected value analysis is a special way of determining severity in risks. To do this, we must measure the probability of the risk in numbers between 0.0 and 1.0. Of course, the numbers 0.0 and 1.0 themselves are not used, since these would mean that the risk was either an impossibility or a certainty. If the risk is a certainty, it should be put into the project plan as a required task. If it is an impossibility, it should be ignored. The values for the impact of the risks are estimated in dollars or some other monetary value. By evaluating the impact and probability this way, we can multiply the two values together and come up with what is called the expected value of the risk. This value for severity has quantitative meaning. The resulting value is the average value of the risk. In other words, if we were to do this project many times, the risk would happen some of the time and not happen some of the time. The full cost of the risk each time it happens is the impact of the risk. Of course, since the probability is less than 1.0, the risk does not occur each time. Adding up the cost of the risk each time it occurred and dividing by the number of times the project was done would give an average value. This is the expected value. The expected value is extremely useful because it gives us a value that could be spent on the risk to avoid it. If the cost of avoiding a risk is less than its expected value, we should probably spend the money to avoid it. If the cost of the corrective action to avoid a risk is greater than the expected value, the action should not be taken. The same is true with the other risk strategies. If the difference between the expected value of the unmitigated risk and the mitigated risk is less than the cost of the mitigation, then the mitigation should not be done. If the difference between the expected value of the non-transferred risk and the transferred risk is less than the cost of the transfer or insurance premium, then the transfer should not be done. The expected value of several risks can be summarized by their expected values into best case, worst case, and expected value scenarios as well. The best case scenario is the summation of all the good things, but none of the bad things, that can happen in the project or sub-project. It assumes that all of the opportunities will occur but that none of the risks will materialize. The worst case scenario is the situation that assumes that none of the good things will happen but that all of the risks will happen. The following example illustrates the use of expected value and a best case, worst case scenario. Figure 8.5, example expected value. Suppose a project has a 65% chance of being completed successfully and earning $2 million. It also has a 15% chance of earning an additional $3 million in revenue, and it has a 20% chance of an additional cost of $700,000. It can be seen in figures 8.5, 8.6, and 8.7 that for this project the total expected value is $1,610,000. The best of all situations that can occur is that the project earns $5 million. The worst possible situation is that the project loses $700,000.